Hello, everyone. I'm Ed. I'm from Seldon, and my job here is I'm head of developer relations. Today, what I'm going to do is I'm going to take you through serving different types of models, some of the different techniques we can do, and look at how the technology that Seldon provides can solve some of those pain points when it comes to deploying things at scale. So to start with, what I'll do is I'll just kind of do a bit of a background, right? I'm sure a lot of you guys know this already, but if we kind of take from my experience in the field, definitely that data scientists are now really good at building machine learning models. It doesn't really matter the framework, the type of machine learning model, deep neural nets. People are pretty good, and there's tons of really good educational resources out there, and people have been able to learn. We're also getting better at versioning, saving models, storing them, that kind of thing. But that's kind of where data science is starting to hit a wall. What happens is that organizations have hired these data science teams. They've built a ton of models, shown a load of value in a Jupyter notebook that yes, we can predict sales for the next quarter, or we can recommend good products to our users. What we're now at is the point where those models need to get into production, right? And that's why you guys are here watching this serving event. The whole point of this is you want to deep dive in how to get those models out and up and running and being able to scale them. So we'll dig into that. Typically, the first step is people will just write a Flask API. If you can wrap your code in something like Flask, produce an endpoint, great, right? I can then have an HTTP request go in, send some data, receive my prediction back, boom, right? My model is being served, right? That's a pretty good start, and there's actually nothing wrong with this technique. But you'll find that as things start to scale and with different types of machine learning model, you're gonna hit a lot of challenges along the way. So, and I'll just touch on these very quickly because again, they've probably been mentioned already and people will be familiar with them. But machine learning is not just a case of online inference, right? There are batch workloads, highly latency tolerant streaming requests that come in. For things let's say you've built a model that detects fires in a warehouse, right? And that's taking real time webcam feeds. You need to process those frames almost instantly because if there's a fire, you need to be able to react as fast as possible. We're also looking at the huge size of models now, with some of the breakthroughs in architectures like transformers and so on. People are training things with billions of parameters. The model sizes end up being gigabytes or even tens or hundreds of gigabytes. That brings a unique challenge in terms of deploying them. We have the issues of pre-processing, post-processing. As a developer, when I consume a machine learning API, I don't want to have to understand how to encode and decode my, let's say a string for an NLP use case. I want to just send a string, receive a value back, right? I don't have to be building those libraries in to create word embeddings and stuff like that. So we need to be able to do that in production too. And then you have the issue of as I mentioned with the Flask use case, right? If you let everyone in your company, wrap their model in a Flask API and deploy it, right? How do you standardize the API definitions? What do the payload structures look like for that? Are they all different? Do people have an easy way to be able to identify those? That becomes a real challenge as you start scaling. So you need to standardize on those things. And then finally, defining the rollout strategies. It's all very well getting a model into production, having it serve tons of requests, but when I need to replace it, do I have a good way to do that? Can I do it with zero downtime, or be able to push new versions of a model out and test them before I promote them to be in production? So that needs to be tackled too. And then finally, all of these components that you might have need to be able to scale independently, right? There might be bottlenecks that you weren't aware of until you hit production, where you might have hundreds of thousands of requests per second. So the good news is that a lot of these challenges are not new. and that DevOps has been tackling a lot of these already. So with traditional software engineering, which is definitely several years ahead in terms of its cloud adoption and containerization and so on, best practices have now been formed around this. And what it means is that as machine learning engineers, we can take a lot of these DevOps best practices and incorporate them into our products and the way that we do machine learning ops, right? At Seldon, we appreciate that like the DevOps world has pretty much standardized now on Kubernetes. And that's why we think that building everything on top of Kubernetes gives you this like super flexible and configurable layer underneath everything that you do to be able to adopt those best practices that are coming out of the DevOps world. Scaling infrastructure, being able to roll out new versions of things. Those are, sure, they have unique challenges in machine learning, but those are things that software engineering has been tackling for decades, right? And definitely on cloud, at least for the last 5-10 years, right, at scale with containers. So what we did at Seldon, and I appreciate some people will be familiar with our products or open source offerings, but I'm going to go through just a quick high-level view, just so that you understand like some of the terms that I'm throwing out. And then we're just going to dig in and do a demo, because I think it's much more interesting to see live code and things being deployed. So firstly, we have Seldon Core, and this is really what the company was built around. It's an open source deployment framework that sits on top of Kubernetes, right? It deploys and monitors the models, and it creates these containerized microservices for you that you can then interact with through a REST or gRPC interface. It also has this cool thing called an inference graph, which allows you to do like powerful routing, combining of models, etc. I'll come onto that a little bit later and show you it in detail. Then, as a company, we realized that like deployment is not just getting models out there, right? There are some unique data science challenges that come with it. So we created an open source Python library called Alibi Detect. What this does is it has a bunch of state-of-the-art algorithms for drift detection, techniques for outlier detection, and also detectors for adversarial attacks. And this is really important because what we've seen, having worked now with tons of huge organizations deploying hundreds of thousands of models, that getting a model into production, even having a good rollout strategy and good monitoring for the infrastructure is not enough, right? We need to be able to flag drift in real time because we don't have the data science resource when you've got thousands of models to be able to monitor them manually yourself and check the inputs and the feature distributions and so on. So yeah, Alibi Detect, you can use it totally standalone as a Python library. You can run it in Jupyter Notebooks, or you can deploy it on top of Seldon Core. There's also Alibi Explain, which is again an open source Python library, but this time we're looking at interpretability and explainability. So again, all of the state-of-the-art algorithms in here, and one of the great things we do at Seldon is we have a really large and super smart data science research team. So a lot of their job is to come up with novel techniques for drift detection or for outlier detection, or in this case for explainability across things like multimodal models, which is a topic that has been looked at but hasn't really been solved in the explainability field at the moment. So these explaining algorithms can be used for white box or black box. By that, what I mean is just, do you have access to the model's underlying architecture, or do you only have an endpoint to work with, right? And you know nothing about the model. They also look at global and local views. So trying to explain the whole model is a global technique, or trying to explain how a single prediction was made is a local view. And then they work with both classification and regression models. Right, so those are our three kind of core open source libraries. We have a few smaller projects on the side, but these are the big popular ones. Now, what we do as a company at Seldon is we take these and we wrap them all together into an enterprise product called Deploy. What that does is, provides a nice user interface, an SDK, authentication for your API endpoints, integration into a whole load of enterprise systems, as well as obviously, support and maintenance and all the things you'd expect from a top tier enterprise product, right? The architecture obviously isn't quite as simple as just, take the 3 open source libraries and kind of stick them together with a UI. In fact, it looks a little bit more like this, but I don't think we're here to discuss the architecture of how you build a deployment platform. What you guys want to see is the thing in action. So I'm going to show you this, a bunch of different deployments. And what I'll do is I'll talk through them as we go. And hopefully you'll get a good idea of the different features of our platform and some of the underlying libraries that sit beneath it. Okay, so let's start off in a terminal, right? And maybe where a data scientist would start. So in my folder here, you can have a look. I've got this train.py file. So let's open that and have a look at it. And a lot of you will be familiar with this. It's a really, really simple scikit-learn machine learning model that we're training in here. The use case for this, if you're not familiar, it's an iris data set. It's one of the sample data sets you get with scikit-learn. And what it does is it takes the 4 data points on the iris, which is and I have to clarify here that is the flower, the iris, not the iris in someone's eye. And it will then classify from those measurements what type of iris it is. And there are 3 different types of iris in the wild. So you'll see some of these predictions in action when we deploy the model. So it's a very simple model. It's a support vector machine that we've trained here. And you can see it, this is 16 lines of code. And importantly, at the end, we're going to spit out this classifier and save it as a model.joblib file. So I can actually go, let's run that. So jump back into my terminal. Okay, cool. And then you should see, so you'll see the outputs there. This one on the left is the, hang on, which one did we print first? Okay, so yeah, we printed the prediction first and then the actual result second. So what I did was just took the first 5 samples in the test set and then fed it through the classifier just to check that we're getting reasonable results. So that's what it's predicted. And here were the actual labels. So we can see, actually got all 5 of those right. So already it's looking like a pretty decent model. But what we want to do now is deploy that. So we have this model.joblib file that's now saved locally, and you can see it here. But we need to get that into a point where it's ready to be deployed. I appreciate in this example, right? Most people will probably have tools they're working with. It might be a experiment tracking tool. You might have a model registry. It's probably not as simple as just training a model, having it in your local file system, and then deploying it from there. So what I'm going to do here is for this one, I've actually already put it in a Google storage bucket, and that tends to be a pretty common pattern. People tend to store these model files in S3 buckets, Google storage, Azure storage, whatever it is, or some sort of network file store. Okay, so let's jump into our actual deployment platform. And the first thing we're going to do is just create this model. So I'm going to give this name. Let's call it my, I don't know what, we've got iris classifier. Oh, if I could spell, that would help. And then what I'm going to do is just jump through a couple of the, so this UI wizard takes you through like deploying different types of model. You can see for mine that I need to select the scikit-learn runtime. We have a bunch of these out-of-the-box runtimes, which will just take a model file and deploy it automatically onto these highly optimized servers that capture requests and metadata and so on. Again, I'll touch on some of the lower level things in a minute. And then the important thing here is I need to give it this model URI. So that model.joblib file was stored in this Google storage bucket, which is where I pushed my model earlier. And then what I'll do for this, I'm just going to accept the defaults for the rest of this, and we'll look into the things like auto scaling and resource limits in a minute, because this is a really simple model. It doesn't require much. So let's just launch that. Okay, and now what you'll see is that my model goes into creating, and let's jump into the dashboard, right? This might be quite a lot to take in, but for each model, right, we get a bunch of options down the left-hand side, to be able to monitor the model, view the requests. You can actually drill into the Kubernetes resources underneath. We'll look at batch jobs in a bit too. And we also have this, live prediction UI as well, which is really useful just for testing it when it's up and running. And actually we can see, okay, great. If you look on this top right-hand corner, my classifier is already available. So that deployed pretty quickly. Let's run, let me just grab some JSON here, and then we will run a prediction against that. So what I'm doing here is I'm just providing this JSON object. As I mentioned, there are these 4 different features that are being used to predict the type of iris flower. There's sepal length, sepal width, petal length, and petal width. And with those 4 features, actually, you can get a really accurate prediction of the type of iris that you've got. And then, so I can fire that in. Great, I get my response back. And you'll see, importantly here, that I'm getting back the names of the different outputs, which in my case, you'll notice are just 0, 1, and 2. That's because I haven't provided my model schema to the platform. But if you provide the model schema, it'll give you the actual names back. And then the bit that we're really interested in is this here. So this is the prediction I'm getting back. And you can see that, for that first, I passed in 2 arrays here. For the first array, it predicts that it's the second class. And actually for the third, it's not quite so sure. It's like 51% confidence on the second class and maybe 43% on third. So that one's it's not super close with that. But then these are raw values. So we might pass those into like a softmax function or something like that in order to determine which classification we're going to go with. Okay, so you've seen how do we deploy a simple model. We can run a prediction through the UI. In fact, actually something that's cool I might show I'll show it in a second. First thing we'll do is we'll look at how we deploy different versions of this. So jumping back to my dashboard, right, I have the option here to add a canary or a shadow. Let's say that for our example, right, we've trained this iris classifier. We might have done some tests locally or with some sort of testing framework. We have a metric that it is 85% accurate. And then we go and we train a new classifier, and this time we're using XGBoost, and we find that it's actually like 90% accurate. So what we want to do is we want to roll out this new version of our iris classifier, but we don't want to just replace the one we've got, right? We want to roll it out slowly and check that it runs in production and it handles requests properly and that we're getting good predictions back. So what I'll do is I will add a canary. A canary basically allows you to route a very small amount of traffic to your candidate model. And then that way you can monitor it in production. And once you're comfortable with it, you can promote it if need be. And that's what we'll do in this case. So what I'll do here is, let me just, 1 second. I'm going to grab my URI again. There we go. And then, okay, so there's my model URI. So as previously, I trained this XGBoost model and I stuck it in a storage bucket. But this time, obviously, I'm going to pick the XGBoost runtime because it's a different model and I want the optimized XGBoost server to serve it. And then I can choose my Canary traffic percentage. Let's keep it at 10%. I think that's probably good for demonstration purposes. And again, let's just jump through these and set the default parameters for things like resources and so on. And let's launch that. And you'll see, I'm now creating this canary that sits alongside my default classifier. And you can see along the top of this, that 90% of the traffic should go to my scikit-learn model and 10% to my XGBoost model. Okay, how do we test that though, right? Wouldn't it be neat if we could test that through the UI? Well, we actually can. So if I, let's grab the JSON that we were using earlier, and because that was a pretty good example of a prediction request. And let's jump in and do a load test. Okay, so what I can do in here is I can say, let's run it for like, I don't know, 120 seconds. So 2 minutes of load should be enough. And then we just put a payload in. So it's going to send this request, fire it through a load tester at my models for the next 120 seconds. So let's launch that. And then hopefully we'll start to see very quickly that the number of requests on these models goes up, because we only had one request at the moment. While we're waiting for that to get started, you'll find actually this is a name of a model I used earlier. So it is picking up previous requests as well. But eventually we'll see that this will start to go up. So if we're at 4572, when that load test starts to really ramp up and actually firing off predictions. Okay, yeah, we're definitely getting requests now. That number, which was 4,500 or something, has now gone up to 4,610. You can see if I refresh this, yeah, we've had another 50 requests. Yeah, we're getting a decent number of requests through now, and we can see all of those in the UI here, and they should start to be seen on the dashboard. Yeah, okay, cool. So there's models starting to receive lots of requests. Maybe there was just a little bit of lag in it being logged and shown up in the UI here. What we'll see eventually, right, is that the resource metrics for those servers, actually, you'll start to see the CPU going up on both of them. And we can see this independently, right, both for the classifier and then for this Canary down here as well. So what we'll do is we'll let that run for a second. And so you can see again, like I get CPU usage for the Canary and for the original model. Let that run for a second, and then we'll start to see some requests in here. Okay, just going to refresh this really fast. What we want to do is we just want to check that, like, as we're firing now thousands of requests at our models, that we are definitely only routing a certain percentage of the traffic to the Canary. And we can do that by having a look in here. We can see we've had 12,000 requests. 11,000 of them were to this default model, and the Canary's received 1,300. Right, that looks like roughly 10%. It's never going to be exact because it's random number generation. And eventually, as this dashboard catches up, we'll start to see that the requests per second for the Canary are probably about 1/10 of what they are for the actual classifier. So the load test has run, or is still running, and seems to be working fine. We're not getting any errors thrown from this. We haven't crashed any of our deployments. So we can probably skip ahead and say, actually, we're happy with the way this model, this XGBoost model, performs. Let's go ahead and promote that Canary. So what I can do in here is I can say, XGBoost model has higher accuracy. I don't have to provide a note, but it's nice for audit trail, and performs fine under Canary tests. Okay, cool. And then through that, what's going to happen is it's now, you can see that my scikit-learn model, which was on the left-hand side here, has disappeared, and my XGBoost model is now going to replace that. What I might show actually is that one of the cool things about, again, using Kubernetes and being able to roll things out using replica sets is that I can actually still run predictions. It looks like from the UI that it's creating this new model now that I've promoted my Canary. But actually, I can still run predictions, and I'm getting responses back. So in fact, that one happened quite fast because I'm now getting XGBoost responses back. But you'll see, that's happened really, really quickly. And what happens, the way Kubernetes underneath does this is it's very much like a blue-green deployment. We roll out the new replica set, wait for that to become available, and then only once it's up and running and passes all the health checks do we then scale down your old version of the model and then route the traffic to the new one. So you have zero downtime with any of these deployments that you're doing through the UI. Okay, jumping back to the dashboard, we can see our Canaries now up and running. Okay, the final thing we're going to do with these models, now that we've got version 2 of our Iris model running, is we are going to do a batch payload against it. I don't know, let's say instead of classifying models, or maybe we go, let's use this example still. We send a bunch of biologists out and they take hundreds of measurements throughout the day for different types of irises. And then at the end of the day, they come in and they dump all the data into a file, right? Let's take a look at what that file might look like actually. So you can see in here, I've got this iris input data.txt. Okay, so it's just a ton of different values for the different petal widths and sepal widths and so on and lengths. I might want to run that as a batch like every evening once all that data is thrown in to classify all of these values that have been read. So the way I can do that is what I have running here as part of the Seldon deploy platform is it spins up a Minio. Minio is like an in-cluster object storage utility. And what that allows me to do is to basically like stick files in permanent storage alongside my models on the cluster. So I've created a bucket here and I've stuck in that data that I just showed you, this iris input data. And now from my UI, I can create a batch request. So let's create a new one here. Let's give it the input data, which was, I think I called it data iris input data.txt. And then what we'll do is once the batch request has been run, it spits all that data, all of your predictions out into an output file. So I'm going to say, stick it in the same bucket, but this time let's call it output data.txt. Right, that should be pretty good. And then I can set a bunch of things like, number of workers, number of retries, the batch size, and so on. So let's just set 10 workers. And then the final thing I'm just going to put on this is I'm not the best at typing and speaking at the same time, but my secret here. So this is actually an authenticated S3 bucket that I'm accessing. And so I need to use a secret that I've stored in the platform in order to be able to authenticate with it. So I've provided that down here too. And then what we'll do is we'll run that batch job. Now that will take a minute to start firing up. And then again, we'll start to see on the dashboard the number of requests going up and so on. And even more importantly, we'll be able to go and look in our object bucket and find the output data from the thousands of predictions that it's just run. Whilst it's doing that, I'm going to jump on to the next thing I want to show, which is how do we deal with models that aren't really as simple as just a scikit-learn classification or XGBoost classification model. So let's jump out of here. Just clear this, and then let's take the use case of, and because this is a bit of fun, right? Let's imagine that you've decided you think that you are going to be quicker than George R.R. Martin at writing the next Game of Thrones book if you use natural language generation. So you think, right, I'm going to build a machine learning model to do it because he seems incredibly slow at writing books, which is why they ended up, finishing the series with a bunch of, let's be honest, quite mediocre script writers. So there are a bunch of different ways we could do this. Text generation has lots of different approaches. What one of them might be is to use just a simple statistical word model. So if I go into my trigram folder here, you'll see a bunch of files, but more importantly, actually, let's look at the Game of Thrones text first, because this is our kind of training data. So let's have a quick look, right? And you can see this is the whole book, A Song of Ice and Fire. This is what our models are working with. And then what we're going to do is we're going to create a machine learning model, this trigram one, which isn't like, it's not really I guess, I don't know if you call it a machine learning model, right? It's like a statistical model that looks for patterns of 3 words in the training data and then uses those like sections of 3 words at a time to try and predict the next one. So like given this word and this word, at position 1 and 2, what is the most likely outcome for position 3? And you'll see within this model, right, what I'm doing. And the point of this is not to look at different machine learning models, but more to look at deployments. But I import that game of throwing this text. Importantly, I then create this list of trigrams, and those are those kind of tuples of 3 words that are used alongside each other in the text. I then make counters on them and so on, and I have this predict function in here. Now, what you're seeing here, this class, this trigram object, is I'm following a template that I need in order to be able to deploy a custom model on Seldon. So we appreciate that not everything is a standard TensorFlow model or a standard scikit-learn model, right? And often you need to write your own. So we have this Python wrapper, and that's what I'm using here. The minimum it requires in this signature is this init function, which is where basically you can load your model, you do any kind of initialization that needs to happen, and then a predict function, which will take a bunch of inputs and return predictions. Right, it's as simple as that, really. And so you could write, very, very basic Python function and deploy that as an ML model. Equally, you could put all sorts of complex logic in here. You might go out and call, third-party APIs like feature stores, for example, to retrieve features in order for you to pass them into the predict function of the model. So this is my trigram model. In fact, what we can do is we can test that locally. So I also have a test.py, which you'll see just imports that trigram model, instantiates it, and then runs this predict function with, and we'll just use this. Oh, hang on, I'll undo that. I'm using these seed words just to generate some text and see what we get. So let's go down here and run that. Fingers crossed I haven't broken anything when I just accidentally typed something. Okay, let's see. Great. You'll see that the model output was, okay, it started with the dark, and then it said Garrod or Guard. I don't know. I actually haven't read the book, so I'm maybe not the best person to have built this model. Garrod did not seem likely that might be able to think of a people dark. Okay, that didn't make that much sense. What about, he was the last I fear, we must act quickly, makes a bit more sense, but it's clearly not good enough. Swords and torches in hand, I. Okay, these are the 3 sentences that I generated given those seeds. So it seems like it's getting close to making like human readable stuff, but it's a bit like gibberish, right? I don't think we could ever write a book off this. Anyway, let's go ahead and deploy this. So what I will do with this custom Python model, in fact, before I do, let's go and check if our batch job has finished. Sorry, I'm jumping around a bit, but just so that we don't have to sit there twiddling our thumbs for a minute or two whilst the batch fires off like thousands of predictions. We can see, yeah, that should have finished. Let's check. Batch job is completed. And then if I jump into my model storage bucket here and have a look, you can see that I now have this iris output data. Cool, right. All those predictions were done for me by the batch orchestrator. Let's download that and just have a quick look. Okay, so this is all of our output data on the right-hand side here. It's probably a bit small for you to see, but importantly, what I find actually as I look at this is, hang on a minute, I'm not getting the same payload back that I was expecting. I'm just getting zeros for all of my so this ND-array function. So something has gone wrong. And whilst my XGBoost model was fine serving predictions like online, it somehow hasn't seemed to handle my batch requests very well. This is a really good example of something that we desperately want to avoid in production. So how can we rectify that error? Let's jump back into the UI quickly and go straight into our XGBoost model that we promoted. One of the really cool things that the platform does is that all of these models are deployed using a GitOps strategy. So the config that is required for deployment is all stored in a Git repository. That is then used as a hook to create all the deployments, which means we have this audit trail of everything that's been deployed. And I can go and look at that. So let's look at the audit logs for this model. And then we'll roll back to something we know works. So you can see, when I promoted the Canary, it's got my commit message there. And you can see all the diffs across the config if you want to drill into things. More importantly, what we want to do is just roll back to our scikit-learn model. So let's jump in and just hit restore state for this. So I don't know, let's give it a message, XGBoost doesn't handle batch predictions. Rolling back to scikit-learn. Cool, that'll do. And I can confirm that. And because all of my previous deployment state has been stored, immediately my cluster can start rolling back. It's just one of the really powerful things that we think everyone needs to be doing in production, to have this audit trail of what's happened, what's been deployed, and then be able to immediately restore states whenever needed. Also really useful because if, I don't know, let's say your data center or the cloud provider you're using, completely falls offline, right? You've still got this state that can be totally recreated as soon as things come back up again. And now if I jump into my dashboard, you'll see already that's replaced the XGBoost server with the scikit-learn one instead. So we're back and we're happy because now our production system is running as usual. Okay, so back into our slightly more sophisticated use case. We're trying to generate text here, and we're trying to generate Game of Thrones, right? It's a niche model, so we don't have a pre-built server to handle this. So we've written this custom Python code, and then what we do with it is we containerize it. So having created my custom Python model, what I'm going to do is I'm going to build this into a container, and then that can be deployed as any other model can on top of the Seldon platform. So I'm going to use a command called source to image, but you can also just use Docker to do this as well. And all I do is just give it, I need to make sure that I have the, hang on, let me clear this so you can see my requirements.txt file in there so I can get all the dependencies. But then I can just run build s2i build my local folder, and then the what I give is I give it a a builder image, right? And we provide these, right, at Seldon. But the builder image basically takes your Python wrapped model and builds it into a optimized inference container for you to then run on top of the platform. And then what I just need to do is give it a name. So let's call it trigram. Let's call it model AIIA, because I think I have one called something similar. Cool. And you'll notice, right, so this is just building the container for me. I don't particularly need much knowledge in containerization or anything. The only thing I need to be able to do to write these custom models is to understand how to create a Python class with the right signature. And as I showed, it's just as simple as kind of defining that init function and then the predict function. Once you've done that, you can just follow these instructions and it will generate the container out for you. Let's just look at my images, Docker images. So I've got that trigram model I've just built it. Let's just do a Docker push as well. So I'm this container that's now been built is on my local machine. I'm just gonna push it out to a registry. Trigram model AIIA latest was its tag. Okay, hopefully this won't take long. I've got good internet here, so it should be pretty quick pushing live. Cool. And then what we'll see is having done that, right? In fact, let's copy that because we're about to use it. We can now go back into our deployment platform and we can create a new model. So here I'm going to jump in and say, let's create this trigram model. Trigram AIIA, doesn't really matter what type. And then we go next. But importantly here, for runtime, I'm going to pick custom because it doesn't suit, like, doesn't fit any of the like scikit-learn or TensorFlow or PyTorch or whatever. It's a kind of statistical model that I built in Python. And then all I have to do is provide the Docker image for it, and that will then pick it up and run. So the one thing I am going to do on this, right, is I'm going to define some resource limits and put some auto scaling in, because I'm not really sure how this performs. Like, it works okay on my laptop, but we don't really know how it's going to do in production. So let's, I don't know, it's probably okay with a couple of CPU, 1 or 2 CPU. The memory is probably fine. Let's just give it a slightly higher limit. But more importantly, let's enable auto scaling, because I don't know how it's going to perform, particularly when I start to add lots of requests to this. So I'm going to give it a minimum number of 1 replicas. And let's say it can have a maximum of, not 14, let's have 4 instead. And then I can define the scaling metrics in here too. So I'm going to use CPU, and I'll just say the target average utilization needs to be 10%. That way we should be able to see some scaling actually happening when we make predictions. So, all right, let's jump in and do that. We can skip these. And let's launch that. Okay, so that trigram model is now deploying. And when that's deployed, what we'll be able to do is make predictions against it from the UI, like we did with our previous iris model. So let's jump back over here. And then just going to grab test sample for this as well, because we'll use it again in a minute. And when this is deployed, we should be able to run a predict function here. Just giving it a second. This might take a minute or two to deploy, because unlike the previous one where it had to pull a very small model file, this one is pulling that entire Docker image, which might have been, I can't remember what size it was. It's 1.5 gigs, right? So it could take a little bit of time depending on the network. Cool, right? In fact, even just explaining that was enough time for it to be available. So that's now running. Let's make a prediction, and then let's run that. Okay, so in fact, this is just text. So what I'm going to do is fire in the same seed words that I had earlier as this ND array, and then we'll see what we get from the model. Oh, cool. Right, so the first one didn't do so well. The response was the dark A. And this is one of the downsides of using a statistical model like a trigram, is that it's sometimes just gets stuck. It can't find anything in the Game of Thrones corpus that has A plus whatever the word it was going to predict next. So it just reaches the end of a tree. And that's why some are longer than others. So the second one we've got, he was the last thing the Tullys saw them searching wagons and horses, but it kept on her. Yeah, again, we're getting gibberish again, but it kind of does sound like Game of Thrones, so that's pretty cool. Swords and scorpions. There was too slow the frantic beating of her. Okay, again, yeah, quite Game of Thrones themed, but not quite what we're looking for. So what we've seen there is how we can deploy a custom model in there. Let's try and scale that and just show that actually happening. So what we'll do is I'll create another load test again, because that's probably the easiest way to see it. Again, we'll run it for 2 minutes. It should be fine. So I'm going to send that same request that we just did, but I'm going to run it as a load test. And what we should start to see is making these predictions again. This model should take our CPU over the threshold of 10%, and we'll start to create new models, new replicas of our model. You can actually view the underlying Kubernetes resources in here. You can see already it's scaled up to 3 different containers running our model. And as it gets more and more requests, it should hit 4, because we set that as the limit for the auto scaling. So you can kind of see this happening. The other thing that's cool about the fact that it's all built on Kubernetes is that if you are a Kubernetes fan and you're familiar with it, you can actually jump in and inspect and work with the platform directly from the Kubernetes CLI. So if I look in here and I go get my Seldon deployments, I'm still authenticated. Yeah, there we go. So I've got my AIIA trigram model in there. and I can do get pods, right? And you'll see at the top here, these are the important ones because they're still running, my 3 AIIA running. And you'll see actually, this is probably a good one to do. So let's do label. Oh yeah, actually we'll just rerun this one again. But you can see that the first one is like 4 minutes, 9 seconds old. So that was when it first deployed. And then it started to receive load and it deployed these 2 more. And they seem to be handling the load test right now. So maybe if we waited and watched it for another minute or 2, we might see the 4th one spin up if it needs it. It might be that with 3 horizontal replicas of our model running, that's actually fine to handle the load. But you can see from this just how easy it is to set up the auto scaling in the platform. Let's just jump in again, have a look at the dashboard and see what's happening. Cool, yeah, we can see actually, if we jump down and look at some of the resource monitors in here, we can see for example, CPU usage went just above the threshold. That's why it spun up another couple of replicas. And then you can see how the whole thing has jumped and now the limits are 3 because we've got 3 replicas in there rather than 1. And as if we continue to watch this as the load test happens, we'll see that the load test will finish and then the auto scaling will bring us back down to 1 replica again as we're not getting as many requests. Okay, so I'm trying to show you a lot. I appreciate this is quite a lot to take in. So, bear with me if not all of it makes sense. The final thing I want to do is I want to show how do we deploy like something really state of the art, a large transformer-based model. In fact, let's even, let's stick with our use case of trying to generate Game of Thrones text and say, why don't we use something like GPT-2, right? It's a huge model, billions of parameters, but very good at language generation. We're not going to train it or fine tune it on the Game of Thrones text. That would definitely be a good approach. But what we're going to do instead is just deploy the model and then try and make some Game of Thrones type text by giving it the right seed words. So in order to do that, I'm just going to jump in again and show you some stuff in my terminal. So let's clear this. Okay, I've got the GPT-2 folder, and in here I've got this. In fact, I'll show you this save model file. So in save model, you can see what I'm actually using is I'm using Hugging Face to download the GPT-2 model. And then I'm saving that to disk. And then this is definitely one I don't want to push to an object storage bucket whilst you guys watch, because that's incredibly boring and it might take like minutes or hours, right? It's a big model. But what's happened is I've pushed that to my Google storage bucket, and we can then use that URL to deploy straight to Seldon. So let's jump in here again. I'm actually going to delete this model because I need all the resources I can get on the cluster right now. And then let's do a create. Okay, so deployment name, GPT-2. I'm just going to change the protocol on this one because it's a slightly unique deployment. And then I'm going to deploy this with Triton Inference Server. One of the cool things that has is it allows you to do like GPU scaling, and it supports a bunch of different model types like Onyx. And then my model URI is model bucket GPT-2, right? And the model is called GPT-2. Okay, we're going to skip over some logging parameters. You can set like custom things there if you need to. The resource limits are going to be really important here. So let's give it at least 2 CPUs, limits 4. This isn't a huge cluster, so I can't give it an enormous amount, but I think the biggest thing it needs is memory. So let's give it 8 gigs of memory and maybe a limit of 12. Cool. And then let's not auto scale because otherwise the cluster will try and fall over. And hopefully, if I just hit launch, right, we should, and this is a bit where it could be difficult because it's trying to deploy a very big model. I also might have written a typo in. It could be things like that. Kind of explains that, whilst you can do this through the UI, what's actually really important is when you're looking at like really building a production pipeline, you want to use the APIs. So everything I'm doing here has an API endpoint. You can also do this fully config driven through CI/CD tools, etc. All of the goodness of the back end is is there for you to use whichever way is appropriate for you. In fact, we even have a Python SDK as well. So if notebooks are your thing, you can build, train, deploy your model all within a notebook without leaving Jupyter, which is kind of nutty and maybe you shouldn't be done, but some people like to do it that way. Cool. So that GPT-2 model was actually deployed quicker than I thought. I think it must have cached it from earlier. And the final thing to do then is to just try and run some requests against this. So because the GPT-2 one's a bit like bespoke, I've written some custom Python code here to run requests against it. The important things you need to note in here, this is the input text. So let's use some Game of Thrones-y style text. Some swords, a few bows, one man, right? And then let's say maximum generate 21 words, because otherwise it can take ages and the cluster might fall over. And then I'm defining the payload that then gets sent to, and then importantly, I'm making these requests to my actual cluster. So that's the IP of my cluster. This is my GPT-2 model, and then this infer endpoint, which will then take the payload and return the response, which I can then decode and turn back into text. Cool. So let's run that. This is the bit where we gotta hope it works. Python predict. Okay. This might take a second. It's like fairly slow inference, particularly on CPU. But thankfully, I'm doing it on my cloud deployment rather than on my machine itself, right? Because doing that whilst trying to record video at the same time, it's definitely going to fall over. Cool. So actually, we can see in the bottom left of the terminal here, we're getting the response back. A man who is a man of the sword. What else? Comma. So you can see like each of these inference requests for the new word takes maybe like a second. Again, one of the reasons I don't want to generate too much, right, is we'll have to sit here waiting for a long time. A man who is a man. Hopefully it won't get stuck in a loop where it just says a man who is a man who is a man, right? Sometimes that happens with generative models. Oh, yeah, that's pretty cool. Context aware. Okay, cool, yeah. So the input was some swords, a few bows, one man. And what GPT-2 has generated there, live from our kind of Seldon deployment, is some swords, a few bows, one man, a man who is a man of the sword, a man who is a man of the bow. And then I guess it could have continued. That's really cool because what you're seeing in there is some of the clever stuff within GPT-2 to understand the context of like previous sentences. Because it knows there are swords and bows referenced earlier, it's actually said, reference the two of them alongside each other as well, and in a fairly human linguistic way. So maybe we could write a new Game of Thrones model like this. Who knows, right? The final thing I want to do just before we close this off is let's just change the input text, right? Given we're playing around with GPT-2, it'd be a shame not to have some fun and see what it thinks about the AI Infrastructure Alliance. So let's go and make one more inference request. There we go. Oh, cool. Yeah, there we go. It's done. So that's really cool, actually. The AI Infrastructure Alliance is the largest and most comprehensive group of researchers and engineers working to develop and implement AI technologies. The Alliance is and then it stops, right? Because I only asked for 20 words. That's really cool. That sounds like a proper sentence. It's almost true as well, right? I don't know if it's the largest and most comprehensive group, but that's definitely the aim of the AI Infrastructure Alliance. So it's good to know that GPT-2 has predicted the future there. That's really cool. So yeah, with that, I'm going to jump back into my slides, right? Because I've shown a ton of things. One thing you saw at the end there, in fact, just going back to my code, right, was that in order to make requests against something like GPT-2, I was doing like input encoding and then output decoding and firing like tensors at my model. As I mentioned earlier, that's not necessarily like the easiest way to deal with things. Particularly as a software developer, you're not going to know how to do that if you just want to be a user of the API. So one of the cool things we have in Seldon is this concept of an inference graph. A really simple one might just chain two models together. It might say, take the output of model 1, feed it straight in as the input to model 2, and then predict something else, right? That's a really simple example, but it allows you to combine models. You can also do much more complex stuff. Let's say, for example, I wanted to do some sort of analysis on a customer. I wanted to, extract some kind of keywords and concepts from their biography, but I also maybe want to look at some numerical data about them, their transaction history and so on. So maybe I feed some in, my data gets fed into the numerical model, which is model 1, and then I just get numerical outputs. But the one that reads the biography is like a natural language model. So I need to use an input transformer, then use the model, then the output transformer, and then feed all of that back into the combiner, which might make some sort of assessment or categorize my user depending on the combination of their bio and the statistics that they provided. That's the kind of thing you can do in Seldon. It's kind of really cool feature, and one of the things that we think is really important because it makes your models way more useful for actual end users, right? The whole point of deploying things to production is to get to a point where engineers, developers, users can just use those models without having any understanding of the model itself. And having a powerful inference graph definitely helps you there. Final thing or two to touch on is, so we didn't really look at metadata in there, but each of the model endpoints, you can query the metadata in there, and you can retrieve the schema for the inputs, the outputs, etc. It also supports additional metadata that you might want to capture on there. For example, things like, training run, hyperparameters that we use to train the model, version numbers that you might have in other tools like MLflow or whatever. Maybe even, data versioning tools, right? Those tracking IDs all the way, you can pass them all the way down your pipeline so that when you make a request to a model server on Seldon, exactly that was, it was this version of this model running in, this container, which was trained using this framework at this time using this data, right? So you've got that full auditability all the way back from, prediction all the way back to the data that was used to train it, regardless of which framework you're using, which is really cool. And then final thing I'm not going to cover them today because, we have a monitoring and explainability event separately, but we do have a ton of stuff in the platform for other things, particularly model monitoring. We have a model feedback endpoint where you can capture, did my model perform as expected? For example, if users are providing manual input or you're relabeling things, you can provide that reward feedback to the model and track those kind of metrics like accuracy live. There's full request logging. You saw some of it already in the platform, but the ability to look at every single request that's come in and look at what was the input, what was the output. Being able to audit that is really important, particularly for companies working finance, stuff like that. And then all the monitoring capabilities for data science type stuff like drift detection. And then feature distributions. We automatically will check the distribution of features that are coming in. You'll be able to look at those within the UI. You can compare statistical stuff against. And one of the cool things actually is you can upload your training set as a reference data distribution. So that allows you to then monitor your real-time requests and say, oh, is my current distribution of features similar or not to my reference data? And you can visualize all of that within the tool, as well as detect it using drift detectors. And then I mentioned as well that we have explainability algorithms that you can run alongside these models, so that for example, my let's say my iris model that we were looking at earlier, I could just hit the iris/explain endpoint, and I get an explanation for that. For example, if we're doing a local explanation for an individual prediction. So you can say why did it make this prediction? And I can get that response back, which was really cool. So yeah, tons more to look at next time when, Seldon, I'm sure, will share loads of this stuff. But most importantly, thank you, right? That's been a hell of a lot of information for me to throw at people. I wanted to do a lot of live coding and showing deployments live. So thank you for bearing with me at points when it either didn't work as smoothly as you'd hoped, or we had to wait a minute or two for things like load tests to spin up. But yeah, please, fire away with your questions. I'm keen to answer them, or get in touch with me. There's my Twitter, my email, and LinkedIn. I'm active on all of those. So yeah, thanks very much.